Okay, so if we continue this discussion, again, I'm trying to zoom into a much tighter scale. I talked about bioturbation initially. I'm just trying to bring it back to you again to say, okay, think about, again, the impact of those organisms, they are living organisms, the movement. Think about the impact of changes in conditions, you know, changes in the rock type, laterally and vertically. Think about how they impact connectivity. Think about how they impact compartmentalization, and how ultimately it impacts you as a production engineer, as a production geologist, as a subsurface scientist. So that's what you're seeing here. I think I talked about this one. And then here you see all these clay drips, what they do. Clay are basically the same clay that you know. Okay, so they are major contributors to differences or variations in reservoir property in the lateral and the vertical sense, either as clay balls or as clay lamina. They reduce the effective porosity of reservoir rock. So you see that it's all coming together. Okay, and then here you see this little this is just an evidence of how bioturbation, in other words, activities, evidence of movement of this organism, how they can enhance or not enhance the quality of a reservoir. In this very case, if a particular individual moved from this part to this other part, so it now broke this barrier or this baffle, which was originally separating this compartment from the compartment below. So moving across actually creates some kind of opening. Okay, so that's one way that bioturbation or evidence of activity of the past life in this context has actually enhanced the quality or enhanced connectivity in this reservoir. In some other case, it may not, especially if that pathway has been filled by muddy materials or clayey materials, and in other words, plugging that hole. Okay.